Are you ready? Are you ready?
I am ready.
You ready? All right. Class?
Yes.
Woo! Thank you. Good job. Yeah. Man. All right, so we're doing 7.5 today. Thank you for being excited to be here. You know what? I feel it. I really do. I really do. All right, so today on this set of notes, you are going to write page number 21. Now, as I go through the notes and I check your notebook, you know how many people did not put a page number on it? A lot. And so they're just piled up somewhere in their notebook. And so did I go through trying to find it for you? No.
No, I didn't.
I have big fat zero. This is for you to try and get your life in order. Okay? Okay. All right, we're going to do modeling data, exponential, logarithmic, and quadratic functions. So, the NumWorks calculator is mandatory for this. If you try to use Desmos, you're going to kick yourself in the teeth. So, right here, what we have is, we're going to deal with scatter plots and regression lines. So we have to have, hey, just have a seat, man. Dude, seriously, you've been up for too long. Sit. Thank you. You're like blocking everyone. Anyway, so data presented in a visual form as a set of points is called a scatter plot. Right? Okay, there we go. A line that best fits the data points in a scatter plot is called a regression line. So my blue line right here would be a line of best fit. For example, the graph displays the relationship between literacy and child mortality. Each point represents a country. So, smarter kids are?
Dumber. Smaller.
Or higher up on the
Less they're going to die. Childhood mortality.
less chance.
So you could read that danger sign, right? That's it. Don't eat this. There we go. Yeah. Like when you get that new pair of shoes and you get that little packet that says "Do not eat." Yeah, there we go.
I chewed that.
What?
I chewed that one time.
Dude ate it.
I chewed
You chewed on it? Why?
I don't know. Like it said, do not. Like if something said, do not touch.
Man,
I'm
who you
gonna touch
talking
it.
to?
Like in the museum, I'm like I'm gonna touch it. Like you know.
Oh, yeah, no. Okay. We got to keep you away from sharp objects. All right, so now, for those other people still following along, okay, definition of exponential function. The exponential function f with base of b is defined, no, like this. You guys should have done this last year. Should have. Should have, okay? Some people did not. I'm not, listen, whoever your teacher was, good, bad, indifferent, not even at the school, whatever, you should have, but I'm going to teach it as if you never learned it.
What? It's okay.
I'm going to use small words for you, okay? We learn it good. Okay. Where b is a positive constant other than 1. A positive constant other than 1, and b has to be greater than 0, and what did it say? B1. Okay. And x is any real number. Any real number. Real numbers. Okay? Not imaginary numbers. Real numbers. Good. Positive constant. And it has to be greater than 0. So we're going to start plugging in some values here. For those people that were working on the homework 7.5, this looks a lot like that first problem, right? Very good. So let's do our NumWorks calculator. Go into calculations. So go to home, hit calculations. You can, but I'm going to show you the calculations right now. So we're going to do the calculations. So it's going to be that first part, and then it's going to be 2 to the x, and we're going to start at -3. So calculation, okay. So it was 2. And I'm going to show you how to do the raise to. And that one is right here. So x, and my first x I'm going to have is -3, right? I'm going to hit OK. Yeah. So it's right here below the backspace, the x raised to the y.
I got it. Indeed, I did get it.
Yep, and then it also gives you a decimal of that one. So let's do the next one. 2 raised to the -2. Next one is 2 raised to the -1. Very good. 2 raised to the 0. 2 raised to the first. 2 raised to the second. 2 raised to the third. So I went through this step by step so you guys could actually see. Now let's go through and fill in our table because you guys just did those. We started from -3 to 3. So this is going to give me 1, 8. Or if you want to put 1, 2, 5. Yeah, there we go. And this one would be 1, 4 or 0.25. That's a 5 over there. This one is 1/2 or 0.5. This is going to be 1. This is 2, 4, 8. So this is a whole lot like that first problem on 7.5. A lot of people struggle with just understanding what it was asking for. Now, x, y. So I'm going to put my x, y's together. X was -3. My y, I'm going to put the fraction because that's a little bit easier for me here. -2, 1/4. -1 is 1/2.
0 is 1. And then it'd be 1, 2, 3, 4. Oh, 3. I apologize.
There we go.
Bing bong.
All right, so hopefully you guys are going through there, filling in your notes because that's what you're supposed to be doing too, right? All right, I'm going to move on. You have it on your calculator too. So, for this one, this is a graph of that. This is a graph of that function we have there. So, you could just go right here. And so it's nice, smooth, no holes, and it is continuously, and it is growing exponentially. Now, we're going to use this. We're going to use this, and we're going to use this and plug it into the numworks to do the regression for this. We're going to compare different things. So I'm going to start right here at 1950. Whenever I have something and it starts in a certain year, if it starts in that certain year, that year is going to be your x values on the bottom here is always going to be 0. The year needs to start at 0. It's almost like certain people paying attention to me right now, okay? The year has to start with 0. So in 1950 is going to represent 0. What do you think 1960 is going to be?
10 years.
10. Very good. There's 10 years apart. 1970 is
20 years.
20. 1980 would be 30, and so on, all the way down. Okay, so there's going to be 20, 30, 40, 50, 60, 70. So by the time I get to 2020, that is 70 years. So it would be 70 for that number right there. And then the y values are over here on this side. The population, they give you the decimals for the population over here. Now, we're going to use this, and it's on your graph right now. and we're going to plug it into the numworks. So let's go ahead, hit home. Now, this one is where regression. We're selecting regression here. So are you writing yourself a note that you know where to go?
On 8.
We're doing regression. Now, it gives me data here, so X and Y. So we said the X value was 0, right, at 1950. Now, if you look at the chart to the left of it, what was the Y value at 1950?
Wait, what do you say, 1950?
Yeah.
60. No.
3?
Look right here. There is a number on it.
2.6? 3 or 2.6?
It's 2.6. That's the one I want for 1950. So these are where you're getting your Y values from. So this is going to be 2.6.
The second one, where it says Y1?
Hold on. And so we're here. 2.6 would be my Y. The next X value is going to be what? What do we say 1960 was?
10 years.
10 years, right? It's 10 years. And then the Y value there was,
What was that?
the Y value,
3.0.
3.6.
here, let's go back. So look, we're on this one right here, 3.0, right? So that's for the 1960, which is, we said, is the 10-year mark. This one right here is the Y values. And let's go all the way through.
And just do that? Yeah.
And the next one's going to be
20.
20 years. And the Y value was
3.7.
3 point what?
7.
7.
10.
30 years.
It was 4.5.
4.5. Next one is 40 years.
Maybe 5.3.
5.2. 5.3.
Yeah.
Is that what you said? Okay. 50 years. 6.1.
Yeah, for 60, it's 6.9.
Okay, 60 is 6.9.
Yeah.
Yeah. And then 70 is 7.5.
There you go.
Right?
Yeah. 7.5.
All right, so I'll leave it up here for a moment while you're doing this.
Sean does.
What?
Yeah, for Sean. Yeah. It's pretty long. Actually, it's in the back.
All right, so now that we have this here, let's go ahead and I'm going to go back up. And now this time I'm going to hit graph. And it should go from 0 to 70.
No, I'll just go down. Don't do nothing yet. Oh, you must grab.
I'll follow you up on the ground. Oh, shit. Oh, better grab it, better. Bro got dirt on his bag.
All right, you guys, attention up here, please. Huh? Okay. All right, so now from here, I graphed it. Now I want to actually go with some of the next questions it was asking in the notes. After entering the data into the calculator, the graphing calculator displays a linear model and exponential model that best fits. So let's go ahead and do that. So let's do a linear for this one. So I'm going to arrow up. Let's go to regression. I know you guys are writing yourself notes on how to get there and what to do. Very detailed notes on where you go to, right? So we hit regression and look carefully at the regression it's asking for also. mx plus b or a plus bx. ax plus b. So it's going to be, yeah. So they use a's and b's for this one. So let's go ahead and do this first one here. The calculator will automatically spit out some information here for you. It spits out the mean point. The mean point,
You said mean, right?
mean point is the middle for your x and the middle for your y. That's what your mean point is. That's not necessary though, but I just wanted to point out what it's giving you. Now, let's go back up to our stats since we just had it put a line on there. Let's see what those stats say. Let's see what the stats on this one says.
What is this? What is it?
La primera.
Now, so some of these things are going to be asked for as you go through. So if you're ever looking for the mean, the sum of squares, standard deviation, the variance or sample standard deviation, that's important. This is where you're going to find all that. Let's go back up to our graph. And let's look at our regression again. So when we hit regression again, it gives me everything I need for this one right here.
Where you press one? Yeah.
We did linear for this one already. Yes,
So after you press
when that thing gets back.
But there's two linears.
All right, I'm hoping you guys are still tracking on this one. So, here is my model. My R value is what I'm looking for here. R value close to 1 is the best number. R value close to 1 is the best number. Okay, here's my linear, and that's the equation. Now let's change the model. What was the other one we had to compare?
The first one?
What's the note say? What did it say to compare?
Y equals ax plus b.
We already did this one.
I mean, y equals ab to the power of x.
So exponential, right?
Yeah.
Exponential, and it's going to look like that. So let's go down and find an exponential.
The first one?
Yes, it is the first one. Right here. A times b to the x.
Looks like this one. And then you go to regression?
And all you have to do is hit OK. There we go. And it gives me a new line, doesn't it?
Oh, that's cool.
So it gave me a new line. But what did I say I want to have?
Ahí dos. La primera.
What did I say I want to have?
Oh, okay. I figured.
An R value. So I went back here.
Oh, okay. I got
I want an R value close to 1 as possible.
you. Wait, let me check. Wait, what was your question? The first one. Yeah, the first one.
So let's take a look. So my exponential model, and it said round to what?
Open the cover.
3 decimal places.
So
3 decimal places. So it's going to be 2.676
2.67.
times, okay, 1.016 raised to the x. And my R value is 0.993. Good. So let's write that down now. So my first one is going to be, what was my number? 2 point what?
2.375.
Times, what was my number? 1 point what?
1.275. Right? No. What are you talking about?
Wrong number.
0.16.
0.16. 0.16. Close, raise the x, and my R value here is 0.993, or is it 994? 993. Okay. That's my exponential. Write that down. Because you're going to have to compare these before we go too far into this.
Mr. Pachi.
Yes. Say what again? Say what again?
We're going to put his do it.
Yes. 1.016. I'm sorry.
That's common next to you.
Yeah, it's a comma
Okay.
because it's separating that from the R.
I'm just making sure.
Now let's go back to the. I'm going back to linear. I'm back on the linear now. Now, as a linear,
In the back. It's Dr. D.
Okay.
It's Dr. Mr. Styles.
0. Hey, please pay attention. 0.074.
Yeah.
Or,
Look at the 5, right?
oh yeah.
The 5 is going to make that 3 go up.
Yeah.
Okay, the next one, and that's x2 plus, there we go. We get that one easy.
Yeah.
So, 0.074 plus 2.375. Now, what was my R value here?
Your R value is 0.998. Yeah, that 0.998.
There you go. And I said, I want my answer where? Where do I want my answer? It's got to be close to 1, right?
Yeah. I'm about to say
I want my answer to be close to 1. Close to 1 is possible. So I have to look at this and see which one is closer.
linear.
The linear looks like it's closer, isn't it?
Yeah.
Okay, that's good. So, you got one? Okay. So the linear is closer to the model.
Yes.
So that one is a better fit.
Yeah.
So how well do the functions model? Okay. So this one is the better fit. So this one works.
That's not.
Yeah.
Nice answer. Yeah, that's the
That one's the good one.
Okay.
Now, using this with 3 decimal places all the time is important. We're going to get some problems later on that you might actually need a 4th decimal place. because they're really close to each other.
Okay.
So anyway, okay, so that's how those fit. Now, by one projection, the world population is expected to reach 8 billion by the year 2026. Which of these functions serve as a better model for this prediction? Okay, so now, let's see. I'm going to try both models, and then I'm just going to guess for this one. So let's see. All right, right here. Let's go back to my graph.
Actually, let's say the exponential.
And so what would year 26 be? 2026, what year would that be?
That would be how many years from? How many years that would be from the 7th? That'd be 116 years.
Nope,
Wait, what's the question again?
2026.
Yeah.
What year, what x value is that going to be?
What X value? Oh, he's talking about like.
So
Going up.
the year, the number 70 on the bottom represents what year?
Oh, 2000.
2020. Very good. 2020.
6 years.
Okay.
2020, right? That
Yeah.
makes sense or no?
Yeah.
Okay, so from our graph that we had earlier,
So wouldn't
Oh,
that
so it'd
be
be 76.
right here,
It'd be 76.
so my last year, my 2020, represented number 70, right?
Yeah.
So I want to know 2026,
It'd be 70.
76.
76. So I'm going to just, let's see. All right, so hold on. There we go. Let's trace it over. And let's see what 76 is.
Thanks.
Ah, why is it not working for me?
What is it?
What?
So we don't gotta put it in. Oh no.
Ah, I,
Acho, this is like a sick graph.
no, I can't go to it. So I'm trying to bring it up.
Oh, sorry.
I did it earlier. I just can't remember how now.
Oh.
I never say that.
She's very handsome.
There we go. There we go. I just arrowed down on it. So if you guys are paying attention, I arrowed down till I could finally select on the red line itself, not just the dots. And now I could put in my 76.
Alright, did it.
There we go.
Found it.
I like that.
Why is
What is that going to be? At 76, it's predicting y would be 7.9664. And that's in billions, isn't it? Yeah. Good. So that's not bad. That's not bad. So let's go check the other one. So that's close to 8 billion. Now we're checking the other regression before.
Bill?
Yep.
Yeah, because
And let's go back and change this one back to my
Oh, yeah. Billions. I didn't look at it.
exponential. And I'm going to go ahead and I hit down arrow. There it goes. I hit down arrow so it selects on my line. Hit down arrow, it selects the line so you could actually see the X's and Y's now. And I want to see what this one says for 76. At 76, what is the Y value going to be on my exponential?
2.68.
No. That's the equation. That's the equation right there.
8.867.
Okay, 8.869, right? Or
87. 69 or 87.
okay, so either way. Now, serious question. Does this fit the model though?
What do you mean by that?
He said no.
Yeah, that's
Why?
Wrong.
It's got to be close to what?
1.
Oh, not that. What did the question say?
8 billion people. It's over.
8 billion, right?
Over 8 billion.
That's way over 8 billion, right?
Yeah.
That's way over 8 billion. So the exponential model didn't work because it's way over 8 billion.
Yeah.
The linear model gave me 7.9, right?
Yeah. Which
So the linear model, so this would be my linear.
so linear would be more accurate for this.
I thought we already knew that though.
Yeah.
What did we say? 7.98 or something like that?
Yeah.
Something like that.
Okay, let's just say that. Okay, and so that's what we're going to have that, and that's going to be in variance.
You want me to look it up for you?
No, it's fine.
This guy.
Now, a lot of this are just basically step-by-step, little step regression, putting in your data, trying to solve what it's asking for. And right here, guess what? I'm going to leave off on this point right here. Wait, hold on.
Yeah, that one. It's that one.
No. Yeah,
Wait, what?
there we go. So I'm going to stop right here because we just answered all those other questions.
Yeah.
I'm going to stop here. We're going to pick this up on Monday. I want you guys starting to work on, before you forget what you're doing, 7.6, please work on it before you walk out of here so you do not already forget what you're doing. So, don't forget, like, share, and subscribe. Hit that notification button. Support my channel. Buy stuff at the merch store.